Welcome back. In this lesson, we're going to be talking about evaluating algebraic expressions. So we talked about how to write algebraic expressions. Now I'm going to talk about how to evaluate them. When I say evaluate, what I'm talking about is substituting a number in for the variables in the expression. And then, of course, you want to simplify using those order of operations or PEMDAS. The biggest piece of advice I can give is to make sure that you use parentheses. Okay, whenever you're substituting a value in, you want to make sure that you're using your parentheses. So, for our first one, again, I'm going to substitute in -2 for every x that I see. So I have a negative on the outside, then that -2 cubed, plus a 2, then -2 squared, minus 7 times -2 plus 9. So here, again, put a parenthesis around every time you plug that -2 in. And now let's use order of operations. Well, the first thing I notice are I have a bunch of exponents, okay? So the first thing I see is that -2 cubed. So I have a negative on the outside, but then I have -2 cubed. So -2 times -2 times -2 is going to give me a -8. -2 squared, so just -2 times -2, that's going to be a +4. All right, so I took care of all my exponents. Now the next step is multiplication. So when I'm multiplying, negative of a -8 is a +8. 2 times 4 is 8. -7 times -2 is +14, and then 9. So now I've taken care of all of my exponents. I've taken care of all of my multiplying. Now all I have to do is add down the line. 8 plus 14 plus 9 gives me a 39. Now, if you have a graphing calculator, you can actually type that in, and if you're very careful about it, you can actually get to that answer, all right? So let me show you. So here, if I do negative of -2 cubed, oh, I'm sorry, didn't get that first parenthesis. So negative of -2 cubed plus 2 times -2 squared minus 7 times -2 plus 9. So if you're really careful and you write it in the calculator exactly the way that I wrote it out on the screen, the calculator actually will be able to do all of this for you as well. So you can use PEMDAS, or if you're clever, you can also get the calculator to do this work for you. So let's move on to our next one. So here, 7 times a plus 4 plus 3b minus 8. And we want to use a, we're going to substitute in -4, and for b, we're going to substitute in 5. So we're going to have 7, then we're going to have -4 plus 4 plus 3, and then the b is now 5 minus 8. So here, this time we have some parentheses to clean up first, don't we? So in this parenthesis, I see -4 plus 4. So that I'm going to turn to 0 right away. This time I don't have any exponents to worry about. However, I do have some multiplying. So here, this is going to give me 0 plus 15 minus 8. So once I take care of that, now I can finish adding the pieces. 0 plus 15 minus 8 is going to give me a 7. And just a little critical thinking question for you is looking at this. Does removing the parentheses, does that change the value of this thing? So what it's asking is, what if it said this? They want to know if that would change the value of this thing. And I definitely think that it would. Because watch what happens now without those parentheses. Now, now there's no group there, no parenthesis to deal with first, okay? Now I just start multiplying. I get negative 28 plus 4 plus 15 minus 8. And now I just add all of that up. And you get negative 17. So without those parentheses, note, now this 4 is not grouped in with the 7. Okay, so you're losing that 7 that was affecting the 4. So just a little thing to show you just how important those parentheses are. Okay, you absolutely need to make sure that you take those into account. And let's look at this one. So here, I'm sorry, that should say x. So here we're going to let x be 1 and y be 1/2. So I'm going to do 1 over 2 plus 1/2 squared. So 1 over 2, we're going to leave that for now because my first issue is that exponent. So I want to deal with the exponent first. So in the calculator, if I have 1/2, and I'm going to make that whole thing squared, that's going to give me 0.25. All right, so that 1/2 squared, again, I deal with my exponents first. That becomes 0.75. 1/2, oh, I'm sorry, 0.25. That 0.5 is the 1/2. And so now if I add those together, sorry, my mind was thinking faster than I can write, that is where the 0.75 comes in. But again, always thinking of that order of operations, okay? Am I doing these things in the right order? We can also apply these skills as we're writing expressions as well. So we're going to wrap in the previous lesson to this one. We're going to practice not only writing expressions, but now evaluating them. So in football, a touchdown is worth 6 points, an extra point kick is worth 1, and a field goal is worth 3. What algebraic expression models the total number of points that a football team scores in a game, assuming each play is one of the 3 given types? So I'm going to answer that first, all right? So I'm going to let x be my number of touchdowns. I'm going to let y be my number of extra point kicks. And z is going to be my number of field goals. Okay, and I'm trying to figure out how many points do they score? Well, they get 6 points per touchdown, right? So 6 points for every touchdown. They get 1 point for every extra point kick and 3 points for every field goal. So I can use that as an expression of how many total points is this team going to get. So that's the first question, is what algebraic expression, okay? Now they say, suppose a team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. So now the secondary question is, how many points did this team score in that situation? All right. So now we're going to look to see, assuming that they got 3 touchdowns, 2 of the extra kicks, and 4 field goals, how many points did this team score? Well, I don't see any exponents I have to take care of, so I'm going to jump straight to the multiplying. So I have 18 plus 2 plus 12. 18 plus 2 is 20, plus 12 is 32. So this team will have scored 32 points during this game. All right, what about another sport example? So basketball. The basketball team scored by making 2-point shots, 3-point shots, and 1-point free throw shots. What algebraic expression models the total points that a basketball team scores in a game? So here, the first thing is writing an algebraic model for this. Okay, so I'm going to let x be the number of 2-point shots. Y is going to be the number of 3-point shots. And Z is going to be number of free throws. So, and here, I'll write that a little bit nicer for you. Free throws. And so now we want to take into account how much each of these are worth. So for every 2-point shot they make, they're getting 2 points from that shot. They're getting 3 points for every 3-point shot and 1 point for every free throw. So this expression is going to model how many points a team scores in a game, okay, tracking those 3 things. Now, just like last time, to give us a scenario, if a team makes 10 2-point shots, 5 3-point shots, and 7 free throws, how many points do they get in all? So now we want to know how many points does that team get, okay? In a specific situation, how much did that team get? So they made 10 of the 2-point shots, 5 of the 3-point shots, and 7 free throw shots. And so looking at this, 20 points there, 15 points there, 7 points there. So at the end of the game, they got 42 points. And I believe that that is all. Yep. So here, let me put it back in case you need to finish writing. So that's going to be all for these notes. So again, once you're done taking them, writing all of this out, now you're ready to go and work on the worksheet of the same associated skill.